Hey folks, today I want to walk you through a quick example I did for a current talk I give later today actually. So this is kind of my try run, which is a ticket booking example process where I basically say, okay, ticket booking means I first have to reserve seats. So in this case, it's a train ticket, so I reserve the seats. Then I want to retrieve the payment, and I need to generate the ticket. And therefore, I use a couple of other services, in this case, a seat reservation service, the payment service, and ticket generation service. And in order to show different ways of interacting with these services, I use different technologies. So, for example, payment service can be communicated with via MQP, via messaging. The generate ticket service has a REST API. And for the seat reservation, I actually subscribe to the workflow engine directly. And this process I want to automate on Camunda Cloud. Camunda Cloud is a process automation as a service, so a managed workflow engine in the cloud. Let's go. And yes, right. And technology-wise, I'm using a Java Spring Boot app in order to run that process and communicate with AMQP and REST. And then I have a Node.js application that provides these fake services, so they don't do much, but I can interact with them. But also the seat reservation service directly subscribes to Camunda Cloud in this case, right? I come back to that in a second, probably. Yeah, let's go. So in order to run that example, so you check it out here on GitHub, and there, the first thing we have to do is actually we need RabbitMQ for AMQP. So that can be best done via Docker. Where's the problem with my Docker here? It's already running. Okay, awesome. There it is. So I have RabbitMQ running here. Then I need a Camunda Cloud cluster. So you go to your Camunda Cloud console. You can create a new test account if you want to, in order to run stuff. So I do a production cluster for ticket booking example, right? The cluster is directly provisioned for me in the cloud. That might take a bit, but I'm not actually currently not waiting for it. I already have a cluster ID. And what I can do is I can create new clients that can connect to that cluster, basically client credentials. So in this case, it could be my applications. So actually, this connection information is now important because this I need in order to connect to my cluster here, my workflow engine cluster. Let's quickly move to my Java Spring Boot app. So there I have the ticket booking.bpmn. So there's my process, which I know from earlier on. I have an application properties, which is here. And there what you can see is I need the cluster ID, the client ID, the client secret. So I quickly copy this over from my newly created cluster. Client ID, there we go, client ID, client secret, dong. Okay. Okay, that's already pretty good. The second thing I have to do the same thing for my Node.js application. So if we go there, where are we? There we are. So we have the address. Right. This is actually just copy and paste this here. That looks good. So let's go. Now what I can do is I can basically start both of these services. So if you follow along here, next thing you do, you run the Node.js fake service. It's written in TypeScript, so I need the TS node pointed to my JavaScript file, looking into the code in a second, but it should simply start up. What you can see now, it's ready to reserve seats, and it opens up an HTTP port in order to generate tickets. It can't yet connect to my CV cluster. That can mean a lot of things. Let's see if the cluster is healthy. That it looks like this. Should be actually healthy. bum, bum. Looks okay for me. Let's see if that heals itself. So let's do it again. Did I really save everything here? So the environment, that's my cluster. That looks okay. Let's simply try it again. Hang on. Hang on. I might have to go into the folder in order to make the .env environment running, working. At the same time, what I can do, I can run my Java application. So I could do that here, but I do it here actually. So yeah, that works much better. I have to fix the README, but that's why I do that try run, right? And here I can run my ticket booking server. So that's a Java application coming up. So if we look back at the example, so this is now already started. It provides a REST API. It did that subscription to the Cloud Engine, and it listens to RabbitMQ. Now what I want to do is I currently start up this one. And as soon as this is up, what it also does, it deploys the workflow definition, the BPMN file to Camunda Cloud. So as soon as this is up, which should be there in a second actually, is I should see something in operate. Not yet. Deployment is done, started. So we're in the game. In a second. Let's wait for it. There we are. So what I can see is my workflow got deployed, but I don't have any instances yet, which is not too surprising. Now what I can do is I basically can curl to put a request here in order to create a new ticket. That will start the ticket booking process. It will reserve the seats, get the payment, generate the ticket, and then we should be done. And there are a couple of things which are interesting here. So what you can see is like, did I enter already? Probably not. Now I did enter. You can already see that some things are happening here. So you're seeing here that somehow it generated a ticket, it reserved the seats, it received the payment, and it created a ticket, right? And then what you see as well, and that's pretty interesting, you get even a synchronous response here from the REST API. So I have a reservation ID, I have a payment confirmation ID, and I have a ticket ID. So everything is successful. Yay. So that did work. If I refresh my operate instance here, where I can look into the workflow engine, you will see that I have a finished instance. If I look into the instance, you will basically see all the same IDs, and you see the path that it basically took. You can also look into the timing, like, okay, this took a bit, this took a bit, this took a bit, and you get also like the timing for everything. Okay, that's kind of how it works. The walkthrough, like in terms of the code, there are a couple of things probably interesting. One is like if we look on the Java side, so if I go back here on this side, so what I can do there is the first thing is like probably the ticket booking REST controller. So that's actually the method I'm calling when I send over the put request. And this one basically gathers a couple of variables. And then what it does, it don't have enough space here. It creates a new workflow instance. It says, hey, that's the ticket booking workflow, right? In the latest version with some variables. So I prepare the variables up front, not too interesting here. And that's actually interesting, where say with results. So I'm waiting, we call that available workflow outcome. So we want to wait until the workflow really finishes. Then we send that over. This is not a feature, it's a future. And then we really wait for the future to come back, right? And what can happen is that we get a timeout, right? Because what really happens in the background is that workflow instance is kicked off and, for example, waits for the seat reservations or send out an MQP message, wait for a response. So a lot of things can happen why this workflow might not finish in time. And then what we will see is a timeout on the API. I still have to finish the coding here, so it should be a different HTTP code. Didn't have time to do that, sorry. But it's still on my list. But if everything is fine, I get back all the data and can send back a response. Okay, so far so good. How does the workflow look like? The first is the reserve seats. That's what we call a topic type. So we wait for somebody who can reserve seats, who subscribes to the workflow engine to be able to do that. This one, in this case, is in JavaScript. Hey, computer, why are you now? So that's the seat reservation service, and in this case, it subscribes to reserve the seats. So that's like the same string here, right? So that's important. Then it reserves the seats, and if there's not any error which we want to fake, we basically complete that job, and then the workflow will move on, right? On the Camunda Cloud side. So this is the JavaScript worker. This is the Camunda Cloud side. Then it moves on. And this one, retrieve payment, in this case, is handled by the Java application, not the JavaScript application. So here we have a generate a retrieve payment adapter. In this case, it's Spring Boot. So I basically say, hey, this is CB worker for this type. Then I have my Java code. In this case, I'm using Spring in order to send over a message via MQP to a certain queue name. Then it's on Rabbit. And then I'm done, right? Then I complete the job. That means the workflow on Camunda Cloud moves on and now waits for the response message of that payment result. The response message is triggered from the JavaScript code. So we have the fake payment service, which basically also connects to Rabbit, right? It consumes messages on the request queue, and then basically what it does, it sends a response on the response queue. That's the only thing. It's kind of a like just a loop, right? It gets a message, it sends something back on a different queue, and that means on the Java side, we can wait for that. So there's a receiver where we say, hey, we want to listen to a certain queue on Rabbit. Okay, we get some payload, we read some data from it, in this case, the payment request ID, and that's interesting. And then I come back to that in a second, and then we publish that message to the BPMN process. And in BPMN process, BPMN also knows the concept of the message that has a name, message payment received, right? That's the message name, so that's a correlation here. And then we have to define a real correlation, like, hey, there's exactly one waiting process instance. Which one is that? And that's interesting. So what we do is here, on the workflow model, we say, look into the process variables. There is a process variable payment request ID, and we want to use that for correlation. Why is there a variable payment request ID? Because here in the sending, I'm not sure if you saw that, we generated one, payment request ID, it's a UUID, and we store that in the process variables. So whenever we arrive here, we have that payment request ID. It's unique for that one communication, and it's also added to the message, right? So when it comes back, we read that request ID and we say, okay, the request ID is also part of the response, so we can unwrap it from the response and correlate based on that. Very easy from the idea. And then we basically send over the message to the workflow. That means the workflow will continue from here and need to generate the ticket. In this case, this is REST, right? So in order to talk REST, what I do is in Java here, I programmed another worker for generating the ticket, right? That's this. Where I basically, in this case, don't generate an AMQP message, but use the REST template in order to call an API. Basically here, the endpoint. It's all very simple. I just want to showcase a couple of things, right? So it's just the fake ticket generation service, which is here in JavaScript, right? So it listens to this port, and whenever I get a GET request on /ticket, it generates a ticket ID, again a UUID, and returns that, and this is then unwrapped here, right? And then this task gets completed, right, with a ticket ID, and then we're done. And then the workflow finishes, and we can read even that ticket ID from the original client, right? Because everything worked like smoothly, happy path. Awesome, right? Okay, that's pretty cool. Let's look at two failure scenarios I can simulate here. So the first, like, I can do something like, okay, I have to look it up to be honest. Hang on, I added that to the README here. Right, I can say simulate booking failures seats. So what does that mean? That basically means here the reserved seats will throw an error and says the seat could not be reserved. Right. So if we go there, what you can see is like I get back a response immediately, right? It says reservation ID null, blah, 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 success equals false. So I couldn't book. That's what it says. Okay, great. How does it look on this side? So if I go to the ticket booking, I see there is the latest process, and it basically just went that path because there was this error, right? Coding wise, very simple. Here I said, hey, if there's a simulate booking failure seats, then I don't complete with a success, but I complete the task with an error. And this error is picked up here from the BPMN. And this is why I go down this route. Okay, cool. That's one failure scenario. The other failure scenario I have here is I can say failure is ticket. And that's a different breed. So what happens if I say failure ticket, what you can already see is that this call is blocking for a while, right? So what happens at the moment is that the workflow, and we can see that in operate, is not yet finished, probably, right? And you can see that there is a so-called incident happening. An incident here means that something is wrong. So if I look into that, I see there's an incident. I can even look into the incident and see, hey, there is something like happening where it says failed to invoke method, call generating service, blah, blah, blah. And here it is, could not connect to HTTP server. So that's kind of the typical, hey, something in my environment is not working. What you can also see is that there is some retry going on because here it says no more retries left. So it tries that a couple of times actually, if it can reach the other peer. But if the network is down, the network is down. I can retry here, but it will not help me to resolve the issue. But as we're in a demo environment, one thing I could do is as this is simulated, right? So if you look at the code, generate ticket, it's very easy. If ticket equals the variable thingy here, like simulate booking failure, I throw the error. So in order to resolve that, I could now restart my ticket service in reality, but in the demo, I can just say ticket is okay. Just change the value of the variable, apply that, And now I could say something like, okay, now retry. Like retry what you're currently doing. And in this case, the retry will actually resolve the problem, right? Because now the simulation is no longer failing. And we can already see that the ticket is generated here and the workflow continues correctly. So I added these two failure scenarios actually because I wanted to make sure that you understand these differences. Like the first is like if another service is not available, that's clearly a technical problem with a technical solution. It means restarting the service, fixing the firewall, whatever it is, and retry. Retry can fix this, right? So it's good to create an incident, to wait there, and let some operator resolve that. It doesn't make any sense in scenarios where there is an error that needs a business solution to it. Like, hey, the seats cannot be reserved. A retry will probably not solve this, right? You have to think differently about that. So the business reaction to things is important. Whereas here it doesn't make sense to model it in a way like, hey, the ticket service is not available. If you model this, you model it each and everywhere, and that doesn't make any sense. Okay, so that's a very important difference. The other thing that's interesting here is that, like, as soon as the happy path is not as happy because whatever, it takes too long, the message is lost, the service is not available, the workflow engine keeps the state persistent. So it will set up from where you're currently at, like the incident. Even if the REST call you had here times out, right? So we're waiting for the outcome, but we can't wait forever. So at a certain point, we normally hand back a 202, say, hey, this is your booking reference number, and we have no idea if it worked or not. Please ask again later, right? That's something I will add in the example, hopefully soon, but not today, right? So that's important to keep in mind. As soon as you have this distributed system in the back, where you say a payment is probably messaging, generate ticket is REST, it's a remote communication. You have all these kind of things. You can't provide a synchronous REST API here that will work in each and every case. It's simply impossible. What it can do, and that's what I did here, is like best effort. In, let's say, 99% of the cases, it's fine. Here's your response. But sometimes it doesn't work. But then still we have the workflow, and that will finish sooner or later, right? So I hope that made sense in a way. For everybody that already knows a couple of these concepts, it might help you to walk through a bit of the code in order to understand how to work with Camunda Cloud. And that's all I have. Thank you so much.